Welcome to Math 1324, Section 7.3. In this section, we like to look how we can count numbers of outcomes. So in our first problem here, we're going to solve this problem two ways. One is using a tree diagram, and the other is to use something called the multiplication principle. So what we want to make is a four-letter code word. So our code would have one, two, three, four pieces, and they want us to use the first four letters of the alphabet. So A, B, C, D, and no letter can be used more than one time. So essentially there are no repeats. So a tree diagram, and here we see a few of them, lets us look at all the outcomes. So you start here on the left and you see I could have an A, a B, a C, a D, or an E. Well, first off, there is no E because we could only use the first four letters. That's one reason why this one is wrong. Also, there's no more levels. This is only one level just for this very first position. Similarly, this is not correct because I have A, B, C, there's no D, and there's also only three levels. Let's see, what about the next one here? So here we have A, B, C, D. Oh, here there's again an E, so that's not good. Plus there's only two levels. So this tree diagram, let's see, A, B, C, D, that's good. There are four letters to pick for the first one. And then I can't have repeats. So A doesn't appear in level 2. I could have a B, C, D. If I had B in the first position, then I could have an A, but no B, a C, a D. So this looks good. So there's four in the first position. That builds on the multiplication rule here. There's three each I can pick for the second position. When I get to the third position, I only have two choices because you see I used A and B, so I'm only left with C and D. So there's two. And finally, when I get to the fourth position, there's only one choice left because I used an A, B, C, and now a D. And similarly here, if I picked a D, an A, and a B, then the only thing left to pick is a C. And so the multiplication principle says multiply up the counts for each of the positions. And so 4 times 3 times 2 times 1 is 24. All right, in question 2. A college offers 2 courses in history, 2 in science, 1 in math, 4 in philosophy, and 2 in English. So let's see. If a freshman takes 1 course in each of the areas, how many selections are possible? Well, let's see. History, there's 2. Science, there's 2. Math, there's 1. Philosophy, 4. English, 2. So the multiplication principle says 2 times 2 times 1 times 4 times 2, and we get 32. If I can only take one introductory course, so I'm only taking one, well, how many courses are there for me to pick from? Well, 2 plus 2 plus 1 plus 4 plus 2, which is 11. So there are 11 classes in the pool to pick from, and so that's how many selections are possible. In question 3, we have a 3-letter code. So here I've got 3 positions. And we can use the letters E, A, J, H, and N. So there are 5 letters. And if no letter is repeated, okay, so let's see. I could pick 5 letters for the first position. But once I picked one of these, there's only 4 left to pick from. And finally, once I make that selection, there's only 3 left. So 5 times 4 times 3, and I get 60. What if they all can be repeated? So I could have E, 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 J, E, A. So I can have repeats. Well, then there's 5 to pick for the first letter, 5 to pick for the second, and 5 to pick for the third. And so I have 5 times 5 times 5, and I get 125. Now the last one is a little bit different. Again, 3-letter codes, but adjacent letters must be different. So it's kind of, I can have repeats, they just cannot be next to each other. So I could have E, A, E. I could have J, A, J. So I can have repeats, just they cannot be positioned right next to each other. So let's see, for the first letter, I can pick from 5 letters. Since the next one cannot be the same, well, there's only 4 left to pick from. Now, what about this last position? You might think at first, well, why isn't this a 5? Well, let's see. For example, if I picked this E, one of my 5, there's only 4 left, and A could be one of them. So now picture there's an A here. How many choices do I have for this letter once I picked A? Well, E is back in the pool, so there's still 4 again to pick from. It's not a 5 because I can't have A. So 5 times 4 times 4, and we get 80. In question 4, we need to have some deductive reasoning. We have this picture here, and this picture is called a Venn diagram. So here's A in this shading of blue. Here's B in this gray part. Now, in the middle where they overlap, we use this mathematical symbol, the upside down U, for intersection, or the part that's in common between A and B. And then they've labeled for us the part that's outside of the intersection. So all of this is A. The common part is the intersection, and this is A intersect B complement. B complement is everything outside of B. Similarly, this little piece is everything outside of A, so A complement intersect B, and U is everything all together. And if you label the piece that's outside of A and B, so all of this stuff out here, that's the intersection of each of A and B's complements. So, what do they tell me? They say the number of things in A, so all of A is 20. But if I look and I see the part in the intersection is 15. So if the little piece in here is 15 and all of A has 20, then this little piece has got to be a 5. And if B has 60 all in it and the little piece in the middle is 15, then the piece out here has got to be 45. Now, all of you, everything in this whole picture has got to add up to be 100. Well, let's see. If this is 5 and 15, that's 20. 20 and 45 is 65 all inside. Then there's got to be 35 outside. And after that, you simply fill in all the numbers that they're asking for. And in our last problem, we have a combination lock. It has 4 wheels, so 4 positions. I can use the digits 0 to 9. There are 10 of those. So if there's no repeats, well, it's easy. It's just 10 times 9 times 8 times 7. And we get 56 times 90, which is 5,040. If I can have repeats, that means I have 10 choices for each position. That's 10 to the fourth, which is 10,000. And finally, in C, if successive digits have to be different. So you see, I can have a 10 and then a 9. So I got to pick something different than the 10. But now for the next position, again, I could pick a 10. And I could pick again a 9. So there's 10 choices for the first one. Once I picked one, there's only 9 left. Once I picked one here, there's still the first one back in the pool, and so there's 9 to pick from. Once I pick this position, there's again 9 left in the pool, and so I've got 10 times 9 times 9 times 9, which is 7,290.